All right, so we're up and running. All right, well, yeah, clicky keyboards are cool. M model, excellent. Yeah, when I was in school, IBM made a type of typewriter called a Selectric, and Selectrics were converted into terminals on some of the early machines, and they were the best typewriters in the world as far as I'm concerned. They were very mechanical, and they just had a feeling to them when you typed. I mean, it was almost like it was reading your brain and typing for you. Never found a keyboard that I was as fast on as an old Selectric. But some of the mechanical keyboards, especially like cherry red keys for me, get pretty close to that feeling. So Logitech clicky keyboard, awesome. Yeah. And good friends are the ones who don't mind when you like make lots of clicky noises on your keyboard.
Just gotta tell them to focus on your keyboard.
That's right. Yeah.
Don't worry about my keyboard. Focus on yours.
Yeah. Although one of my best friends as an undergraduate, he would occasionally, we were working in a lab. He would occasionally come up and he would like pick up my entire terminal and like carry it to the other side of the lab and put it down, as in like, you type too loud. Please work over here.
Very, very
Yeah.
passive aggressive. I like it.
Yeah, yeah. All right, let's see. My brain feels scattered this week. How many people here feel like their brains are scattered this week, right? I mean, I think that's probably everyone. I'm definitely
Got going
there.
on like 2 months, you know.
Yeah, yeah, right. This has been a really fast quarter, but it's also, I think, been really intense. I mean, maybe because it feels like it's been in such a compressed time, but I think everybody is pretty cooked right now mentally. So hopefully break will be a chance to kind of like recharge our batteries for winter.
Yeah, I think as far as the computer science classes, because I'm in your 215 also, and those have been fun classes. You know, they were real cool, abstract, but kind of what I'm into. But I think physics is what's burnt me out.
Oh, okay. Yeah.
Little too much work, I think, in that class.
Mm-hmm. Yeah. This um, last year for most students, um, you've got physics, you've got a 200 level CS course, possibly two of them, and usually some math thrown in. And it's generally a pretty brutal collection of courses um, for this last year.
It's good we don't do it the first year. More people would drop out.
Yeah, right. That's probably true. Um, and honestly, it's good prep for a university, because university, it'll feel very different. And if you're going somewhere with semesters are different from quarters. They're longer, which feels like you have to wait longer till you get to the end of it. But there's upsides to that also. I mean, you can go a little slower, you can get more in depth, and you kind of like get your motor running, in tune with a particular subject, and you get to take advantage of that for a lot longer than, with a quarter, especially like summer quarter, where you just kind of get things going, and all of a sudden it's the midterm, and then all of a sudden it's the final, and it's over.
Still kind of scared that maybe Harper's TA with time against him grading my stuff.
Oh yeah, well, that's a bit of a an archetype or a stereotype. Um, there are certainly TAs who, any TA's gonna do a reasonable job of grading, and take your stuff pretty seriously. Just don't give them an excuse to take shortcuts. Like if you forget to put your name on an assignment. All right, let's see. The final for this class is Wednesday, correct, and it's from 11 o'clock to 12:50. So same time as class normally, but on Wednesday. And the exam will be available on Canvas. It will open up at 11 o'clock. But I will be in Zoom for the entire 2 hours, and I recommend being in Zoom just like on the midterm, so that if there's corrections or clarifications that I make, you can see those. No, go ahead and do an attendance ping now. And yeah, it'll be the same format as the midterm, so it'll be a file that contains the questions. You type up your answers, save them as a PDF, and upload that, as opposed to a Canvas quiz. All right. Oh, let me make a comment on winter quarter also. Only about 2/3 of the people in 224 have signed up for 222 so far, and that's a little worrisome. So if you're computer science major and your intent is to transfer to a university this coming fall, you almost certainly need CSE222. Unless you've taken it before or you're going somewhere other than WSU, you're going to need 222. And one of the sections is almost filled up at this point. But I've only got about 41 people signed up, and there's about 60 people in 224. So about a third of the class between the two sections has not enrolled yet. So I recommend enrolling as soon as registration opens for like every class that you plan to take. And then if you need to make changes later, you can make changes. But, you know, classes fill up quickly. A lot of sections of different classes are already completely filled, and you're going to be on a wait list if you haven't signed up. So do that as soon as possible. And if there's a particular section of 224 that's really important to you, if you really don't want to be online, or you really do want to be online, right, make sure you sign up as soon as possible. And I think registration is been open for everyone for a while now. That dishwasher didn't get run, by the way.
Okay, yeah.
Okay.
Thank you.
Yeah. And that was muted. All right. So any questions? We're just going to keep going through that study guide for the final. But any questions, things you want to talk about beforehand? All right. Well, let's just keep going through this then. Yeah, go ahead.
I do have a quick question. It was one that I was looking at for the. I guess it's kind of far down in the C program one.
Mm-hmm.
It's right after string length, string CMP. I can't remember. What is that?
String compare?
Oh, string compare. Okay.
Yeah, yeah.
I don't think I ever used that one, but.
Okay.
Okay.
So in C, you know, strings are, you know, car, S1, 120, S2 bracket 120. So there's a pair of strings, and maybe we're assigning them values, maybe we're doing fgets, things like that. At some point, if we want to know, are S1 and S2 the same strings, right, we do not want to do this. This is almost always going to be false, because this is asking, are S1 and S2 pointing to the same exact byte in memory? And if they're not, this is going to say these are not equal.
Oh, so that's not asking the value of S1 and the value of S2. It's saying, like because that's like a pointer, right?
It's a pointer. And so this is literally asking, are the pointers pointing to the same location?
Okay.
And usually what we're interested in is if we look at the characters in this string and the characters in that string, are those characters exactly the same? And so that's where we would say if string compare S1, S2 is equal to 0. And this string compare will return 0 exactly when these two strings are the same, character by character, same length.
Okay, so 0's true. Anything else to be false then.
Yeah, yeah. And in particular, if S1 comes after S2, this will be something positive. If S1 comes before S2, this will be something negative. So it can also be used to like alphabetize strings. But usually we just care, are they the same or not? So 0 means the same.
Okay.
All right, and logistics-wise on the finals, so you can use your notes, you can use your textbook, you can use copies of your old code that you've written yourself for the ODPs or for the programming assignments. I'm okay if you use the manual pages. If you can't remember the order of the arguments for FGETs, you can use the manual pages on Unix man space FGETs, for example. And that's it for resources, right? Um, and you shouldn't need a whole lot of resources, right? It's mostly going to be stuff that you're going to come up with in your head. But those are the only things you're allowed to use. You're not allowed to use a compiler. You're not allowed to use an editor that completes your syntax or things like that. Um,
There's not going to be any curveballs, right? Most of it, or all of it, should be stuff we've seen or done
it
before.
should be pretty straightforward, yeah. Let's see, will there be a curve after the exam? It's hard to say, but generally yes. So for example, the ENGRCS page says that a C goes down to a 73, and that's pretty extreme, right? If you get a 72 in this course, right, I'm not going to give you a C minus for that. So a grade of a C will generally go down a bit lower than a 73, probably somewhere in the 60s. Um, but it really depends, right? Because, sometimes I think I'm writing a really good exam or giving really good programming assignments and everybody just really struggles and the grades in the class come out really low. And in that case, I'll set a curve accordingly. Um, Sometimes, especially when I started teaching, I thought I was writing really good exams, and everybody got like 90s on them and so on, and so those didn't get curved. So, um,
Yeah, let's do one of those exams.
yeah, right. All right, let's see. So we left off with processes, right? And processes again, just sort of basic behavior: fork, return value, control Z to suspend, resume in the background or foreground, ampersand to run in the background, kill to terminate a job, PS to look at information about jobs that are running. So file systems, everything we do in Unix, we're dealing with a file system, um, and so there's a hierarchy of directories. When you log in, you're in what's called your home directory. My directory is home Nick, so I'm in a directory called Nick, underneath a directory called home, underneath a directory called slash. Slash is the root directory. If I say ls slash, I can see all the stuff in that root directory, including home. If I say ls slash home, I see everything in the home directory, including Nick. If I just say ls or ls home Nick, I see everything in my home directory, which is all of these files and directories. And some of these are also directories, and some of the things in there are also directories. And so CD lets you change your directory from one directory to another. PWD shows you what directory you're in. And so you should know, that there's this hierarchy of directories. You should know about CD, PWD. Also dot and dot dot. So dot is a synonym for your current directory. And if I say, ls dot, that's just my current directory. It's the same as ls. But if I say ls dot dot, it means move up one directory. So 224 is my current directory. Dot dot would show me home Nick files. Or if I say cd dot dot, that puts me in home Nick files. If I say cd dot dot again, that puts me in home Nick. If I do it again, that puts me in home. If I do it again, that puts me in slash. And if I keep doing it after that, it just leaves me in slash. You can't move above that root directory. And if I just say cd, that puts me in my home directory. And I can also do things like ... which says move up to home nic files slash 215. That basically moves me up, over, and down. So now I'm going to be in home nic files 215. So ... and ... hidden files are files that begin with a period, and they're no different from any other file except that by default ls doesn't list those files. And so, for example, in my home directory, if I do ls, I see this set of files. If I do ls-a, I see a lot more files, because -a is also showing me files that begin with a period. But they're no different from any other file. They're just files. They could be programs, they could be text files, they could be images. It's just that ls by default doesn't show me those files. So it's a convenience. We can put files in our directory that we don't want to look at every time we say ls. Permissions and change mode. So if for example, I have a file with a script in it like main, let me make a main2. So here's a file called main2. And there's these permission bits that say what are different categories of users allowed to do with this file. I'm allowed to read and write this file. People in the group, which is Nick, are allowed to read it and write it. Other people on the system can only read it. None of us can execute it, so if I try to execute this, it says permission denied. So the change mode command lets us change these permission bits. So for example, each of these groups of 3 bits, we can write an octal number corresponding to it. And to form that octal number, we write a 1 if we want the bit turned on, a 0 if it's turned off. So if I want to execute this file and read and write it, that's 111, that's a 7. If I want other people to be able to only read and write it but not execute it, that would be a 6. If I want people to only be able to read it, that would be a 4. So this will say the owner can read, write, execute, people in the group can read and write, and others can only read. And now if I look at it, I can see that read, write, execute for me, read, write for the group, and read for others. And since I have execute permission, I can go ahead and run it. Alright, we should know how to set variable values. So, variable equals stuff. No spaces anywhere around the equals sign, otherwise bash will complain. But basically variable equals stuff, and it sets your variable equal to that stuff. And if I set x equal to 2 plus 3, I can look at the value of x by saying $x, and it's 2 plus 3. It's a very literal kind of thing. If I say x equals date, and I echo $x, it's just equal to date. So by default, these assignments are very literal. If I want to do arithmetic, $paren, some expression. And this is the only way we're allowed to do arithmetic in this course. There's other ways to do it in bash, those don't count, expr, things like that. So I want you to know $paren, and then you can write an expression in here. $sign gives us the value of a variable. If I just say echo x, it's just going to give me an x. If I say echo $x, it'll give me the value of that variable x. We haven't done a whole lot with exporting, but I'll mention it here anyway because it's useful, right? I've got this variable x which has a value, date. If I start a new bash shell and I look at x, x doesn't have a value. Because these variables that I set up are local to this current shell. Which means if I run a script, well, every time I run a script like main or main2, that runs in a separate instance of the shell. I'm starting from scratch, right? So if I make a script called show x, that just shows me the value of x, right? I know that x is equal to the word date, but if I run show x, it tells me x doesn't have a value. Okay, that's because when I run show x, I'm sitting in a separate shell. If I want to export the value of x to other shells, I can say export x. And now when I say show x, it says x equals date. I don't think you're going to see that on the exam, but it's a really useful thing to know. Alright, built-in variables, you got $1, $2, $3, and so on. Those are the arguments to a script. $question mark is the status of the last command you executed. $, we don't really need to worry about that, but that's your process ID. So if I echo $, that's my PID. If I do a PS, bash has process ID 30,087. Well, that's what $sign is. $number tells me how many arguments were passed to the current script. $* is the set of all the arguments typed out one after another. So it's $1 followed by $2 followed by $3 and so on. So here's the test script that basically prints out $number and $*. If I just run main, $number is 0, $* is blank. If I say main, this is so much fun, $number is 5 and $* is, this is so much fun. Alright, can we go over C-type is space, also F open, F close? Definitely. And I think that might be what we're up to. Those are under C. Let's see, exporting variables. Alright, yeah, let's switch gears and talk about that. C-type is an include file that gives you a set of useful functions, including things like is space, is upper, to lower, and so on. So just look for like is space. So all of these helper functions. So for example, if we want to convert a character to uppercase, there's a to upper function. If we want to know if a character is lowercase, there's an is lower function. There's an is it a punctuation, is it a space, is it upper, is it alphanumeric, is it an alpha, is it a digit, right? We never want to look at ASCII codes. ASCII codes are very 1960s, right? They're US centric. They don't work with, programs written in other countries where people speak different languages and don't use, the same symbols we use in English. So these will work for other character sets and so on, right? So don't ever write general purpose code that uses ASCII codes. And then same thing with converting. If you look at to lower, this will convert a character to lowercase or uppercase, right? And all of these things are defined in ctype.h.
Is that only for characters specifically?
These are only for characters, so if I wanted to convert a string to uppercase, I would go through it character by character and change each thing to upper. And this doesn't change C, right? It returns a character that's the uppercase version of this argument. So if you look at return value, the return value is that of the converted letter, or it's the original character if there was no conversion. And those are useful to know in life. Alright, so that was from down here. Alright, you should know the dialog command at this point because you did a whole programming assignment using dialog. What do I expect you to be able to do on an exam with dialog? Basic operations. So be able to display information in a box, be able to read input from the user in a box, be able to display a calendar. Those are probably good enough, but I want you to be able to work with these things in a Unix environment. So for example, don't just display a calendar, but be able to take the date that the person chooses and save that in a variable, which means getting into the dash dash output dash FD business to capture standard out inside back quotes, and stuff like that. Or, you know, if you want to display the value of some variable in a dialog box, being able to use that variable with a $ in front of it as one of the arguments to dialogue. So the kinds of stuff you did for PA4. I'm not going to ask you, you know, to make some complex radio list or debug, you know, something with a dialog menu or something like that. But basic operations, in particular.
Like which output we would like? We'd rather use like an input or a info box instead of a dialog box, or the text box, or
I don't know. I might say use a text box or use an input box or something like that.
Okay.
And you can always try to work with me on this, right? You can chat me in Zoom and say, hey, I don't remember how to do an info box. Is it okay if I do a text box? You know, or you could put a note on your exam saying, you know, I don't remember how to use an info box, but I did this instead, right? But you can use the man pages, so you can do man dialogue.
Yeah, I remember there was one that I preferred over the other because it had an OK at the bottom.
Oh yeah, yeah.
I like that because it gives the user time to read it. It doesn't just go away. You know?
Right, right. All right, GCC. So you should know how to compile a C program. If you don't, then it's been too long since we did C. So GCC, the -O switch to specify an output file, -C to say don't make an executable, just make an object module, which we'll link later. And then -G, which says I want to use debugging symbols, and things like -LM, which says include the math library. So if you want to do square roots, right, we need to include -LM in the GCC command. GDB for debugging, so you should know basic debugging commands, including how do I compile to include debugging GCC-G? How do I debug my program? GDB space program name. How do I start my program? Start. How do I continue it? Continue. How do I print the value of a variable or an expression? Print. To set a breakpoint, break space and the name of the function or the line number you want to break. Step and next to step into or step over a function. And that's probably enough for GCC. And I might, you know, ask you to show me the GCC commands you would type to, you know, get to this point of your program and then see what the value of this variable is, or something like that. Or the GDB commands. So basic GDB. Alright, makefiles. So you should understand how to write a makefile, and the makefiles that we've written for our C assignments, right, should be sufficient, as long as you understand what's going on in those. So the idea of compiling a project in pieces, of having, you know, 3 different .c files, and we compile them with a -C switch to build an object, and then we link those together to make an executable, and doing those as separate steps so that if we change one file, we don't have to recompile every .c file in the project. We just compile that one file and then we relink. So what I've been calling a proper or a good makefile. You should understand that, and to use the makefile, the command is just make. And make will look for makefile in the current directory, and if it finds it, it will try to make whatever the first target is. And there's also these other targets like clean and install and stuff like that we just use to trick make into doing other things for us. Make clean being the one we used in projects to basically delete object files and the executable. Alright, regular expressions. What I want you to know from these is the idea of, you know, specifying a pattern that we're trying to match. And a pattern can be a sequence of characters, but it can also be a period to mean any character, or it can be something followed by an asterisk, which means any number of that something. And so if we do a dot asterisk, it's any number of any characters. If we do a underscore asterisk, it's any number of underscores, right? So you've done a bunch of these for PA5. So matching, anchoring a caret at the beginning of the line, $ at the end of the line. So we can look for a pattern that's specifically at one end or the other of the line. So those are the anchors. And then grouping things that match a pattern inside parentheses to say, hey, take the thing that matches this, put it in a register, and then using that register on the replacement side by putting a backslash in front of the register number. And first set of parentheses goes into register 1, second into register 2, and so on. And I'm not going to go too extreme on this, but you know, that worksheet that we had a few weeks ago of things that you can do with regular expressions, that's a good one to go through and review to make sure you're up to speed on different types of regular expressions. Said we're not going to get into the whole programming aspect of the different types of instructions and different ways to match patterns and so on and so forth. The only thing I really need you to know from said is doing substitutions. So said space quote substitute old new. And if I list a file name after this, said will read from that file and apply this pattern and generate the results to standard out. So it's a basic substitution. If I don't specify a file name, this will read from standard in, which means I can redirect from a file, or I could take some command and pipe it into said. And that's the version that we did most in PA5. And then if I put a /G after this final slash, this says do the substitution as many times as you can on each line. If I don't have the /G, it says do this once. And as soon as a substitution is made from this pattern, it moves on to the next line. And that's all you need to know about said for the exam, even though said does a lot of other stuff. Awk is similarly a subset. Basically, I want you to know how to use awk to print out fields. So the main syntax is awk, quote, curly bracket, print. And then you can print whatever you choose. So for example, I could say, let's print the second field, followed by a comma, followed by the first field. And now this will, read from standard in. It will break the lines it reads into fields based on spaces by default. And this would print the second field, a comma, and the first field. So you can use it to rearrange fields on an input line. And again, I can name a file to be processed, or without a file name, it'll read from standard in, which I can redirect or I can pipe something into. And the other thing to know on awk is the uppercase F switch, because by default fields are separated by spaces. If I want to take fields separated by commas, I could say -F comma. If I wanted slashes, I could do -F slash. But that's as deep as we're going to go on the final for awk. We're not going to get into the whole programming and associative arrays and awk and stuff like that. All right, so that's, I think, a pretty good synopsis of the Unix stuff, which again, 11 weeks of working in Unix at least, you should be fairly comfortable with most of these. All right, bash programming. So if you want to control how a script is executed, the first line has a shebang, which is a number exclamation mark followed by the name of the program you want to use to run the script. And so for us, it's typically $! /bin/bash, which says if somebody just types the name of the script, use bash to execute it. More generally, anytime we have a number sign, it's a beginning of a comment, and the stuff after that is ignored. But if the first line of our file is a comment that begins with a number exclamation mark, then it's got this special treatment, right? But it's got to be the first line. If you put this later on in your program, it has no effect. It's a comment that's completely ignored. All right, we talked about special variables. We talked about $question mark. We've talked about variable assignment. If statements, conditional statements. So go back to that page that was posted in Canvas in the beginning of the quarter that summarizes different ways to do conditionals and loops, right? That's your one and only guide on what's legal and what's not, and the expected format. So the way we do if statements in Bash: if space bracket bracket space condition space bracket bracket new line then body new line fee. Optionally, we can put other conditions like this, or with an or, and so on and so forth. And optionally, after the body of the then statement, we could say else and list some conditions and say fee. And if we want the else to actually be an if, we could say else if elif bracket bracket condition then, and list the body, and then we could have another else if, or an else, or a fee. And these conditions, if you're doing numbers, you use these mnemonics. If you're comparing strings, we want to do either equal, equal, or exclamation mark equal for equal or not equal. Don't forget your dollar signs if you're trying to look at the value of a variable as opposed to, you know, a set of strings that you want to take literally. A set of characters. All right, while loops are the same way, and again, you're not allowed to use for loops except for variable in list. So look at that guide on Canvas. That's how you can use while loops. So while statement is while space bracket bracket space condition space bracket bracket new line do body of the while loop done. And of course, you know, what makes up the body of the while loop? Well, it could be if statements, it could be if then else statements, it could be more while loops, it could be kind of generic bash code, it can be whatever. Body of the if statement could be a while loop or an if loop or whatever. Alright, variable assignment and interpretation. So we talked about quotation marks yesterday. So back quotes versus single quotes versus double quotes. That was kind of magical.
Thank you.
$paren to do arithmetic. Read to get input from the user. Echo to send output to the user. And detecting end of file when reading input. So that's this while read business where we can say something like while read data do blah 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 done. So this is a while loop which will continually ask the user to type in something, and whatever the user types will get stored in the value of data, and then we'll execute the body of the loop. Then we'll come up here and wait for the user to type something. What they type will go into data. We'll execute the body of the loop. If at some point it's waiting for the user to type something and the user hits Control D, that will take us out of the while loop, and we'll come down here after the done. The other way you can do this is you could say something like a forever loop. So I could say read data. And here I could say if the status $question mark from that read is not equal to 0, then break. And a fee. And then the rest of the loop, and then done. This will work exactly the same as that. This is a forever loop which should run forever and just continually keep reading data, but as soon as we read the data, we check to see if $question mark is different from 0. And if it is, then our if statement's going to make a break. Make sure anytime you use $question, you do it right after that read statement. So if I say read X and I say hello and I echo $question, it's a 0. If I say read X and I hit Control D and I echo $question, it's a 1. That tells me I hit an end of file. If I say read X and I hit Control D and I have a comment saying check status, and I checked my status is still a 1. But anything else and my status is going to get lost. So if I say read X and I hit end of file and I say status equals $question mark and I echo $question mark, it's a 0. Right? This is always the result of the previous command. So if you want to use it right away. If you're not ready to do something with the value right away, save the value right away. Alright, if then, while loops, variable assignments, $question, read, echo, detecting end of file. Associative arrays, make sure you know how to use associative arrays. And associative arrays are basically, declare your array with a -a switch. Assign a value by saying names bracket, or whatever your variable is called, your array. Variable name bracket and whatever your index is equals, you can give it a value. So that works just like in C, right? It looks pretty normal. But when you want to read a value from an associative array, you have to use this syntax, $ curly bracket, array bracket, and then the index. If you don't do that, you don't get the right value back. And then the fourth thing to know is this business of looking at the keys, the list of all indexes that we've used. You can get to that list by $ curly exclamation variable name bracket @. And this will be a space separated list of the indices that you've used in storing things in the array. So you can pull things out of the array with that. Again, PA5, right? Alright, C programming in 5 minutes. Basic syntax, everybody should be comfortable with all of these things. Quotation marks in C are slightly unintuitive. If I say single quote followed by a character, this is a character, right? This would be the same thing basically as the integer value 67. That's the ASCII code for the letter C. If I say double quote C, that's some big, long, horrifying 32 or 64-bit number, which points somewhere in memory at where the ASCII code for C has been stored. Right? This is a character, this is a string. Strings are pointers, strings are arrays. Right? This is a really simple thing, it's just an integer that we're having to write as a character C. So that's the difference between like quote versus double quote. You should know how to write comments in C, hopefully. Include basically says take the contents of some other file and just glom it into our file right here. It's a way to avoid continually typing the same stuff over and over and over again. We don't use include to take a function and make that part of our program. We use include to take things like function prototypes, structure definitions, stuff like that we tend to do more than once in more than one file. We can put those things in an include file. And if we include angle bracket, it comes from a standard directory /user/include. If we put it in quotation marks, it comes from whatever directory we specify, defaulting to our current directory. Alright, you should be familiar with modularizing code, breaking down your project into a series of files and compiling and linking those together with something like GCC in a makefile in particular. The things we put in an include, again, are not, .c files that include executable code. They're things that are like header files. So generally function prototypes, define statements, other includes, things like that. You should know about arrays, and in particular character arrays, which we call strings. The notion that arrays don't have a predefined length that we can tell at runtime. So if we have an array of integers, how many things are in there? No way to know at runtime. You got to have something that's keeping track of that for you. With an array of characters, we have a convention, which is at the end of the characters we actually care about, we put character 0. That's the null terminator. That's just a convention, but all the C stuff follows that convention, including things like string length that give us the number of characters in a string, and string compare that we already talked about. We talked about C type, string.h, math.h. These are things that get you functions like string length, string compare, and square root. You should know what the argument business is with a main program, so argc, argv. When you declare arguments for main, it's always an integer followed by an array of strings. This integer tells you how many strings you have, right? And if we don't know how many strings we have, we will probably segfault. If we say, let's see what string 5 looks like, well, I may segfault by trying to do that if there's no string 5. So we always check argc first to know how many arguments we have in this array. Make sure you know how to use scanf, and make sure you do not have to use scanf. Scanf works only in very, very limited circumstances where we're guaranteed that we know what the input's going to look like. If we don't know if the person's going to make a typo or not, right, we got to use scanf combined with something like fgets. Printf for output, fopen, close,fflush, and fprintf, these are for doing I/O to files. So fopen lets us open a file. fprintf will let us print into that file. fgets will let us read from that file. fclose closes it. And fflush forces the output to get sent right away. Fgets we also use for reading from standard in. That's where we read from most, but it's the same command we can use to read from a file. We just specify a third argument of fgets. Fgetc I don't think we've used in this course, but if you want to read a single character, you can use that. You should never use gets. You should understand why, which is that gets lets you read in an unlimited number of characters and store them in a string. And since strings don't have a predefined length, there's no way for gets to know if it's going beyond the end of the string. So we can corrupt memory using gets. Know how to write functions, how to call functions, how to pass arguments to functions, how to get values back from functions. And keep in mind algorithms. So the idea in the programming assignments is to, first of all, understand what the problem's asking, and then decide what are the steps that will achieve the goal, and then how do I write that in terms of simple steps that a computer can do, and then how do I explain those steps to the computer by writing a program. And that's the end of the programming part for the exam, but in practice we would then actually write the program in an editor, we'd compile it, we would test it, we would find mistakes, identify them, debug, and so on and so forth. And just some things to keep in mind in terms of algorithms. Running sums, where we keep accumulating some value as we loop. Flags, where we set a variable to a value to indicate that something has happened. Initialization, where we give values an initial value, and we always need to initialize variables in C. Don't assume that if I say integer I, don't assume I is equal to 0. If I needs to be 0, say I equals 0. And then looping conditionals and so on. Alright, that's the whole course. But most of you already know most of this. Probably, more than well enough to get through the exam. So, send me an attendance ping on the way out, and I guess my closing comments would just be, other than thank you for the quarter, go back, review your programming assignments, your ODPs, your notes on all of these things. Don't get too stressed over this, okay? The things I ask you to do on the exam should be things along the lines of what you've been doing already. So do some review, and come into the exam Wednesday and just show me what you know. While read, you don't have to do anything to detect end of file. If I say while read do, I'll automatically exit this loop when the read hits end of file. So that is checking for end of file automatically.
For my own clarification, can I ask you a quick argc argv question?
Sure.
So argc was the number of input on the command line, right?
Correct. Yeah.
And argv is the actual input. Oh, okay.
Correct. Yep. You got it.
I don't know. It's been a while since we've used that, so I'm kind of looking back.
Yeah. Yeah.
Remembering, but.
And if you're trying to prep for the exam, right, write some code. Write a program that just does a main argc argv and print out argc and argv, and maybe make a loop and try to print out every argument one line at a time. And if you can do that, you know everything there is to know about argc argv, and you can go on to the next thing. Write a piece of bash code that does something with an associative array. Right, reads a few lines, stores them in an array, and then goes through and prints out what you stored. Stuff like that.
Okay, perfect.
All right.
Thank you for everything.
Yeah, have a good one. And if you're in 215, I'll see you in a little bit. If not, I will. I'll see you next week. Good luck with your other exams, and have a good weekend.